All right, well, hello, sixth graders. We're getting here into lesson 2 here in chapter 5. A couple sets of directions we need to look at here today. The first one says write the phrase as an expression. Now remember, an expression does not have an equal sign. And all you're doing is writing the expression. You're not actually going to be solving the problem here on this first section. So it says the product of 4 and 96. Well, the key that we need to understand here is product. And as a sixth grader, we need to remember that the product is what we call the answer to a multiplication problem. So it's the product of 4 and 96. Now, we know that 4 times 96 equals the same thing as 96 times 4. However, when we have these word phrases, we want to put them exactly how they say it. The product of 4 and 96 needs to be written as 4 times 96. The 4 comes first here, so the 4 needs to go first there. And that's all you do. We're going to use a dot for multiplication because x is so commonly used as a variable, and we'll be doing a lot with variables here in our lesson today. The next one says the total of 7 and 11. Well, the total just means we're combining them. We're adding them together. So the total of 7 and 11, since the 7 comes first, the 7 needs to come first in my expression. I'm going to write 7 plus 11. Not hard. The next one, the quotient of 36 and a number y. The quotient of 36 and a number y. I really want you to get into the habit of putting division problems as fractions. First thing we want to remember, the quotient is the answer to a division problem. So whenever you see the word quotient, you've got to know we're talking about division here, sixth graders. So the quotient of 36 and a number y. 36 is the first number here, so it's got to be the first number in our division problem. Y is the second number here, so that has to be the second number in our division problem. We're going to write it as a fraction, 36 divided by y. The fourth one, the difference of a number x and 17. Well, once again, key word, difference. The difference is the answer to a subtraction problem. The difference of a number x and 17. Well, x is the first number that's listed in my word expression in this situation. So x has to be the first number in my subtraction problem. The difference of a number x and 17 is going to be written as x minus 17. All right, let's go ahead and get my second board here for the second part. And it tells us to write the phrase as an expression, then evaluate the expression when x equals 5 and y equals 30. So not only are we going to write it as an expression like we did in the previous set of instructions, but now we're going to solve it. And we're going to solve it knowing that in all of these problems, x is going to equal 5, y is going to equal 30. So this first one says 5 less than the quotient of a number y and 6. Well, first of all, it says 5 less. When it says 5 less, I've got to know that that means it's minus 5 because we're taking 5 away. It's 5 less. If we want to figure out what 5 less than something is, we subtract 5. But it says it's less than the quotient of a number y and 6. So the quotient, that's a division problem, remember, of a number y and 6. So that's y divided by 6. Well, it tells me that y equals 30. So it's 30 divided by 6. Well, I can solve that. 30 divided by 6. I know that 30 divided by 6 is 5. So that's going to be my original expression that needs to be included. 30 divided by 6 is 5, so it's 5 minus 5. Well, 5 minus 5 is not hard. When I evaluate the expression, I get a final answer of 0. This next one, the sum of a number x and 7 all divided by 4. The sum of a number x and 7 all divided by 4. When we talk about the sum, we're talking about the answer to an addition problem. The sum of a number x and 7. So it's x plus 7. My x needs to come first. Okay, so we're going to have x plus 7. All right. And actually, I'm going to go back to this first one. In my original expression, instead of 30, I should have y. That should actually be my original expression. My original expression that I write down should have the variable in it. Okay, and then, like we said, we kind of did 30 divided by 6. That's 5. So it's 5 minus 5 equals 0. The sum of a number x and 7, all divided by 4. Well, x plus 7, and then that whole thing being written as a fraction over 4. So this, and of course, as always, division problems written as fractions. X plus 7 over 4. Well, it tells me that x equals 5. So this is going to be 5 plus 7 over 4. Well, 5 plus 7, all of that over 4. Well, I know that 5 plus 7 is 12. So it's 12 over 4. 12 divided by 4 is 3. When I evaluate the expression, I get 3. All right, next one. 8 more than the product of 7 and a number y. 8 more than the product of 7 and a number y. Well, whenever it says 8 more, and I want to figure out what 8 more than something is, I know that I'm adding 8. When it says 8 more, I know that I'm adding 8. Now it says 8 more than the product of 7 and a number y. Well, the product is the answer to a multiplication problem. And the two numbers that I'm multiplying are 7 and y. So I'm adding 8 to that, so it's going to be 7y plus 8. And that is my original expression. Now I want to solve it. So it's 7 times y. Well, it tells me that y equals 30. So when I figure out what 7 times 30 is, I know that 7 times 3 is 21. Add the 0, I get 210. 7 times 30 is 210. But then it tells me I'm adding 8. 210 plus 8. And I'll just come over here. 210 plus 8, I believe, is 218. And that's the answer to evaluate the expression. Last one here, number 4. The quotient of 50 and the difference of a number, these kind of got faded out here, y and 10. The quotient of 50 and the difference of a number y and 10. So it's the quotient of 50. So that tells me that 50 is the first number in my division problem. I'm going to come over here to the side. It's going to tell me that 50 is the first number in my division problem. It tells me that the second number is the difference of a number y and 10. Well, the difference, remember, is the answer to a subtraction problem. And it's a number y and 10. So that's y minus 10. So I come over here, and it's 50 over y minus 10. Well, so that's my original expression for number 4. But now I want to solve it. I go back to my directions, and once again it tells me that y equals 30. Okay, so y equals 30. So once again, 50 over y minus 10, y is 30. 30 minus 10 is 20. So that tells me that I get 50 over 20. Well, I'm going to go ahead and simplify that, okay? Because remember, I can leave it as a fraction as long as it's in simplest form, but that's not in simplest form. Both of those numbers end in 0, so they're both divisible by 10. 50 divided by 10 is 5. 20 divided by 10 is 2. I get 5 over 2. That is in simplest form. There's no number besides 1 that can go into both 5 and 2. So I could leave that as 5 over 2. Or if I wanted to make it a mixed number, 2 can go into 5 2 times. If I take 2 into 5 2 times, there is 1 left over. My denominator here is 2. So my denominator here is 2. When I evaluate the expression, I get 2.5. All right. We'll talk to you later, 6th graders. This is lesson 5.2. Bye.